Today we will see how to derive the kinematic equations. Kinematic equations. What are the kinematic equations? Number one, Vf is equal to Vi plus At. Second one is Vf square is equal to Vi square plus 2At. Third one is D is equal to Vit plus half At square. Let us derive the first equation. We know acceleration is equal to change in velocity over a period of time. Time elapsed. I will write here as time elapsed. Therefore, A bar is equal to Vf bar minus Vi bar over T. Here, Vi is the initial velocity. Vf is the final velocity. And T is the time elapsed. Therefore, cross multiply this one. At is equal to Vf minus Vi. Or Vf is equal to Vi plus At. This is the first kinematic equation. Now we have to derive the second kinematic equation. We derive the second kinematic equation from the displacement equation. Okay. We know displacement is equal to average velocity multiplied by time. Here average velocity is equal to initial velocity plus final velocity divided by 2. Therefore, D is equal to Vi plus Vf by 2. Or we can alternately write D is equal to Vf plus Vi by 2. Both are one and same. Okay. Times T. Now what I do is, instead of T, I will write the first kinematic equation. From the first kinematic equation, we can write, we know first kinematic equation, Vf is equal to Vi plus At. Am I right? So T is equal to Vf minus Vi over A. This I will substitute here. So what happens? D is equal to Vf plus Vi over 2 times Vf minus Vi over A. This is of the form A plus B times A minus B, which is equal to A square minus B square. So this will give Vf square minus Vi square by 2A. Otherwise, we can write it as Vf square minus Vi square is equal to 2AD, or Vf square is equal to Vi square plus 2AD. Okay, so this is the second kinematic equation. Now we have to write the third kinematic equation. We have to derive the third kinematic equation. What is the third kinematic equation? Vf, we will write here. D is equal to third kinematic. Third kinematic equation. D is equal to VIT plus half AT squared. Okay. This we will solve from the same displacement equation. Displacement is equal to Vf plus Vi over 2 times T. And we know that this equation Vf is equal to Vi plus At. I substitute here. Therefore, T is equal to Vi plus At plus Vi over 2 times T. So from this, D is equal to 2Vi plus At times T, or D is equal to 2VIT plus At square divided by 2, or D is equal to VIT plus half At squared. Okay, this is the third kinematic equation. Now what we do is, based on these kinematic equations, we will solve the problems. Let us solve one problem based on the kinematic equation. Here is the problem. What is the problem? An object is moving at 1 meter per second, accelerates uniformly to a final speed. If the object traveled 5 meters in 2.5 seconds, what was the object's final speed? Here what is given to us? Displacement is given to us. Displacement is equal to data 5 meters. And then time is given as 2.5 seconds. Now we have to find out the average velocity. Average velocity V bar is equal to distance over time or displacement over time, that is equal to 5 meters over 2.5 seconds, that is equal to 2 meters per second. And initial velocity is given as 1 meter per second. We know average velocity is equal to Vf plus Vi over 2. Therefore, we have to input the values here. We have to find out Vf. So this is 2 meters per second times 2 is equal to Vf plus Vi. And then instead of Vi, I directly write the value, that is 1 meter per second. Therefore, Vf is equal to 4 minus 1 gives 3 meters per second. The answer. Now we do a bit difficult problem based on the kinematic equations. Okay. Let us see the problem. Can you see? I hope it is big. Yeah. So a car is traveling at a speed of 30 meters per second, a typical highway speed on wet pavement. The driver sees an obstacle ahead and decides to stop. From this instant, it takes him 0.75 seconds to begin applying the brakes. Once the brakes are applied, the car experiences an acceleration of -6 meters per second square. How far does the car travel from the instant the driver notices the obstacle until stopping? Here, what is the data given to us? Initial speed is given to us. VA is given 30 meters per second. And then reaction time. T is given as 0.75 seconds. This is initial velocity. And then deceleration is given. Deceleration is nothing but negative of acceleration. Deceleration is negative of acceleration. Because here we have given as acceleration is given as negative 6 meters per second square. Therefore, deceleration is the negative of acceleration that is given to us. And what else is given to us? We have to find out how far does the car travel from the instant the driver notices the obstacle until stopping. Here the problem is the car is traveling on a highway and then the driver sees an obstacle. The moment the driver sees the obstacle to apply the brakes, that means there is some time gap between seeing and applying the brakes. We can't do it immediately. There is some small reaction time. That reaction time is given to us as 0.75 seconds. Now we will calculate how much distance the car travels during this reaction time. So distance traveled, I will write here, distance traveled by the car during the reaction time. That we can find out d is equal to vt, velocity times t. And we know the velocity and then time. So 30 meters per second times 0.75 seconds. What is the value we get? 22.5 meters. Now what we have to do is, now after this time, after the reaction time, the driver applies the brakes. When the driver applies the brakes, the car eventually comes to a stop. It will not come all of a sudden. It takes some time to come to a stop. So during that time, the acceleration, the car is decelerating. That means the velocity is decreasing. The velocity decreases slowly and finally comes to a stop. He is not applying the sudden brake. Okay. So here we will find out the distance traveled by the car during the deceleration. How to find out? We have to find out delta y is equal to VIT plus half AT square. This is the equation, kinematic equation we have to apply to find the distance. Or we will use the formula, or we will write it as d is equal to VIT plus half AT square. We know VI, we know A, but we don't know T. Now we have to find out the T. What is this T? This is the time taken for the car to decelerate. taken by the car to come to a halt. That we have to find out using the kinematic equation. A is equal to Vf minus Vi over T. So from this, we will write T is equal to Vf minus Vi over A. Vf is 0 because the car is coming to a halt now. So this implies Vf is equal to 0. And then Va is given as 30 meters per second. So what we do is 0 minus 30 divided by minus 6 gives the time, 5 seconds. Okay, now we know Vi, we know the acceleration, and also we know the time to come to the halt. We substitute the values here and find out the distance traveled by the car. Okay, therefore D is equal to, what is Vi? 30. 30 meters per second times T. T is 5 seconds plus half into minus 6 meters per second square times 0.5.0, 5 seconds whole square. So what is the value here? This is 150 meters. And this is 75 meters. That is 75 meters. Okay. And then here we already found out the distance traveled by the car during the reaction time. So that therefore total distance is given by total distance traveled by the car. (22.5) plus 75 is equal to 97.5 meters is the answer. Okay. Now I give one problem for practice. Okay. Same kind of problem. This is a bit difficult problem. That is why I give the similar kind of problem for you to practice. And you try to do it. And then if you have any difficulty, you just keep the, I think you will not find any difficulty in doing the problem because it is the same problem, just numbers are different. See the problem. You are driving a car, traveling at a constant velocity of 25 meters per second. When you see a child suddenly run onto the road, it takes 0.45 seconds for you to react and apply the brakes. As a result, the car slows with a steady acceleration of 8.5 meters per second square and comes to a stop. What is the total distance that the car moves before it stops? Here, everything, the same kind of problem, like a second problem. And only thing is here, the numbers are different. Suppose if you understood the problem, solving the second problem, then you can easily do this problem. If you have any difficulty, put the comment section. I will do the problem for you. Okay. Thank you. Bye-bye.